If you're developing on an Arduino, for example, this Arduino Nano, which can do almost everything you will need for normal mid-sized projects, then you have several options of connecting to it. One would be directly soldering the cables to the device. As you can see, I did not do that because it's a really bad idea. And you will never be able to change that, or maybe change it once or twice before the board gives up the soldering. So you would probably add some pin headers, and then you can connect either to one of these extension boards where you plug in the Arduino into your pin headers and connect the cables directly here. And it lays out every connection from the Arduino to these screw terminals. So you would have to find your ground and then stuff all the ground cables into that one. Or you can get kind of development board like this one, where you also plug in the Arduino and then you have your cables and you do your connections. And for me, that's not really feasible because it takes a lot of time to figure this out, and it's very finicky and not that much fun to try that out. I mean, you can do some microprocessor stuff, and when you know it's working, you get a PCB. But yeah, it's also really not a good solution to have on your desk if you're not doing this like full time. So I basically created a rapid development board for mid-sized Arduino projects where you can add your Arduino on one side, and it also lays out most of the connections of the board for the user. So you have screw terminals and you can add your cabling, but it also adds all of the voltage options of the Arduino. It adds the option to have a tip 120, for example. So you can connect to some motors, mid-sized motors probably, or lamps or whatever you want. And you have your analog options and some digital pins on that side. And you can also add the SPI and I2C interfaces. So you can solder all of them. And then you have basically the development board I'm currently using for most of my projects. Or you can solder only some of the connections that you will use, and then, well, it's the actual board and not for development anymore, but it's still a fairly small board for me, so I can fit this into many projects. So you would have the Arduino here and a tip 120 here, and so I could connect to a motor, for example, here to turn a drum from a roaster. And different voltage options for, I don't know, sensors, lamps, switches, whatever you have. And some analog stuff. And what I usually like to do is I like to add a Bluetooth module. This is the HC05. So now I have Bluetooth connectivity for my Arduino, and I can connect to an app, I can connect to my PC, and most of all I can remotely upload code, for which you would have this screw terminal right here, and these also always are a pair of the connection to the Arduino and ground. So you can always say this pair is for one switch and this pair is for one motor and so on. And you don't have to stuff like 10 cables into one ground connection, which is just messy. So you would connect a switch to here, for example, and then you can switch if the HC05 will restart the Arduino pin, pull it to ground when you connect, and then you can upload code. And the Arduino will only basically boot when you're connected to the Bluetooth module. Or you can disable the connection, and then you basically can start the Arduino on power up. And you cannot upload code, but you can connect your app normally and get the data you want. And also then you would have the I2C connections. Here are two of them. So for me, this would be like adding this max module, and then you can just plug it in like that. You can have two of them, as I said, and then you can read in two temperature sensors, for example. Or you get the kind of better one, PT1000, for example, and then you can connect them to the SPI slots here, which basically would look like that, but it's not an SPI connection. And then you basically have all the modules stacked here, and you can have your timer module here. This one is a timer, like a real-time clock, and then you would have a clock, and you can turn your project on and off at a specific time or a specific date of the week. And you can measure your temperature, and then maybe you measure your temperature using a PT1000 as well, or you add any other SPI connection here, and these are parallel, so you don't have to worry about the serialization in case some modules don't support some specific kind of serialization. And then you're basically good to go for most projects. But one more thing, Also, I like to connect to like high power stuff. So using an SSR relay most of the time is useful. Like normally for heaters, in a roaster in the heater and an espresso machine for the heater, you can power like 3600 volts for our European German system. And this one you can directly mount to the PCB. So there are two screw holes here for the PCB, so mounting. And then this would actually fit on here as well, like that. And then you can have this basically stuffed like this. You can do a distance however you want, or you turn this around and add a like a heatsink to the SSR if you need that much power, and then you can mount this whole package to something. And then it's a very small package with a lot of functionality, and you can use it in a lot of different projects. So this is what I'm currently using. The link to the PCB is in the description, so you can order it if you want and build it for yourself. And there will be also like two projects following, one with an espresso grinder and one with a new espresso machine, where we basically will replace all the logic of these tools and use this board for that. So look forward for that, and maybe it will help you in your own projects. Maybe leave a comment and have a nice day.